The Northern Lights are one of the most mesmerizing natural wonders you can witness firsthand. The Northern Lights, also known as the aurora borealis, are one of nature's most spectacular displays. Auroras occur when charged particles from the sun collide with gases in Earth's upper atmosphere. These ghostly glows are most visible near the magnetic poles. But thanks to increasing solar activity, they're now appearing farther south and more frequently than usual. Whether you're planning a trip to see the Northern Lights or just curious about the science behind them, here's everything you need to know about what causes the Northern Lights, when and where to see them, and how to spot them from your own backyard. The Northern Lights occur when electrically charged particles from the sun, mostly electrons and protons, slam into Earth's upper atmosphere at speeds of up to 45 million miles per hour, 72 million kilometers per hour. But our planet's magnetic field protects us from the onslaught. As Earth's magnetic field redirects the particles toward the poles, there are southern lights, too, which you can read about below. They interact with atmospheric gases like oxygen and nitrogen. The result is a glowing light show that appears in waves, curtains, or arcs across the sky. The Northern Lights are most visible near the Arctic Circle, but during times of high solar activity, they can stretch far beyond their usual range. What causes the movement and shape of auroras? Constantly changing input from the sun, varying responses from the Earth's upper atmosphere, and the motion of the planet and particles in near-Earth space all conspired to cause different auroral motions and shapes. From these motions and shapes, we can learn about the physics happening further out in space along the Earth's magnetic field lines. Auroras tell us many things about Earth's upper atmosphere, including its density, composition, flow speeds, and the strength of electrical currents flowing in the upper atmosphere. These in turn tell us about the Earth's magnetic field, how it extends into space, and how it changes dynamically. All of this is important for protecting Earth and spaceborne technologies from hazards of space weather, of which aurora is one part. On Earth, the Northern Lights counterpart in the Southern Hemisphere is the Southern Lights. They are physically the same and differ only in their location. As such, scientists expect them to occur simultaneously during a solar storm, but sometimes the onset of one lags behind the other. The Northern Lights are a popular target for budding photographers, and it's easy to see why. Their colorful ribbons of light, dancing to the whims of Earth's magnetic field, are a truly stunning sight. But aurora photography is not without its challenges. Low light, cold temperatures, and the unpredictable nature of auroras make them a rather tricky subject. Though it was Italian astronomer Galileo Galilei who coined the name aurora borealis in 1619, after the Roman goddess of dawn, Aurora, and the Greek god of the north wind, Boreas. The earliest suspected record of the Northern Lights is in a 30,000-year-old cave painting in France. Since that time, civilizations around the world have marveled at the celestial phenomenon, ascribing all sorts of origin myths to the dancing lights. One North American Inuit legend suggests that the Northern Lights are spirits playing ball with a walrus head, while the Vikings thought the phenomenon was light reflecting off the armor of the Valkyrie, the supernatural maidens who brought warriors into the afterlife. Early astronomers also mentioned the Northern Lights in their records. A royal astronomer under Babylon's king Nebuchadnezzar II inscribed his report of the phenomenon on a tablet dated to 567 BC, for example, while a Chinese report from 193 BC also notes the aurora. According to NASA, the science behind the Northern Lights wasn't theorized until the turn of the 20th century. Norwegian scientist Christian Birkeland proposed that electrons emitted from sunspots produce the atmospheric lights after being guided toward the poles by Earth's magnetic field. The theory would eventually prove correct, but not until long after Birkeland's 1917 death.